In the domain of science and enormous secrets, the subject of what existed before the Big Bang has sparked debates and captivated minds for ages. This profound question not only challenges our understanding of the universe, but also tests the very limits of human knowledge. Imagine standing at the edge of existence, staring into the vast darkness, and wondering what lay there before our universe was born. The moment of the Big Bang marked the dawn of humanity, space, and everything we know. But was there a moment before this? Could there have been a state of nothingness, a silence before the cosmic symphony began? And if so, what was it? Or perhaps something far more terrifying existed before time itself. As we delve deeper into this mystery, science takes us on a journey beyond the universe's origin into ideas that defy our understanding. Physicist Brian Cox, known for his exploration of the wonders of the universe, suggests that something eerie might have existed before the Big Bang. He challenges us to rethink our concept of reality and time. In this exploration, we'll examine the science, theories, and astonishing mysteries that could explain what existed before everything. We'll explore ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may just astonish you, but they could also reveal new understandings of our place in the universe. Prepare to dive deep into a world beyond imagination, a world of science where the unknown still looms in the shadows, leaving scientists both awed and sometimes even unsettled. Let's explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what could have existed before the Big Bang, we first need to carefully examine what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became incredibly hot and dense, rapidly expanding to trigger the creation of all matter, energy, and cosmic forces. When we look up at the night sky, we see evidence of this hot beginning, with galaxies spreading out in every direction from a central point. But why did this happen, and was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or peaceful. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and stretched out, almost like a vast vacuum. However, this vacuum wasn't completely empty. It contained a tremendous amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially set the stage for everything that would follow in a fraction of a second. Space expanded at unimaginable speeds until the expansion slowed and the energy transformed into matter, particles, and the forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly swell the universe? And why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching infinitely with tiny bubbles forming here and there. Each bubble represents a universe, including our own. This concept, called the inflationary multiverse, suggests that there are potentially endless Big Bangs and an infinite number of universes. Ours is just one of many. This vast, mind-bending reality challenges our understanding of the very universe and leaves us with the question, what else is out there? The concept of nothingness before the Big Bang is theoretical, not literal, at least according to our current understanding. Even if you removed all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create a tapestry of something even in its most vacant form. Even if we imagine stripping away all these forces, leaving a dead void, the universe would still create new forms of energy. This fact alone puzzles scientists, as it suggests that true nothingness might be impossible within our cosmic comprehension. As we probe further, we find that space itself has properties, rules, and constants that don't allow it to be completely empty. Imagine creating a region with absolutely nothing in it, no particles, no radiation, no energy, but quantum fields and fundamental constants still exist, meaning that this nothingness has properties. For instance, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still briefly appear and vanish, creating a ghostly echo of activity even in what should be empty space. This challenges our idea of a true void and suggests that even before the Big Bang, there was something that scientists are only beginning to understand. One of the most astounding theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible it could continue endlessly. Brian Cox describes an alarmingly vast inflationary multiverse where universes are endlessly created and keep expanding. Imagine each Big Bang as a spark igniting a new universe, while inflation continues in other regions, creating countless other universes. This cycle could, in theory, go on forever. This idea of infinite universes gives rise to a fascinating concept of a fractal universe, where each new universe has the potential to create its own Big Bang. Each universe exists as a separate, self-contained realm, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling, as it suggests an endless multiverse with no ultimate beginning or end. What if our universe is just a speck in an epic cosmic structure, expanding and creating forever? And what if the unsettling truth is that there is no before or after, but merely an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe isn't a collection of matter floating in space. Rather, it's a network of energy fields that fill the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, borrowing energy for a brief moment before returning it. This phenomenon gives rise to virtual particles, entities that momentarily exist and then vanish, leaving behind a faint memory of their presence. The concept of virtual particles challenges the idea of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have complete nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, occasionally producing fleeting particles. This constant activity in what should be nothing suggests that the universe doesn't comprehend our concept of emptiness. The fields and forces persist, filling the universe with a fundamental energy that prevents absolute nothingness. This insight raises an intriguing question. If fields create particles and particles create matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to scientists, it's possible that the dark energy we observe today is a remnant of an energy field from before our universe's formation. Dark energy's properties seem to suggest a vast hidden force that might have existed in some form before the Big Bang. Some theories propose that dark energy, in a much stronger state, may have powered the inflationary phase, allowing for rapid expansion. The existence of dark energy implies that even if our universe were drained of all matter and radiation, this force would continue to stretch the fabric of space-time. This idea leads to a disturbing possibility. If dark energy was present before the Big Bang, it might have shaped the conditions that led to the birth of our universe. Could dark energy be the silent architect of cosmic inflation, or even the true origin of our universe? As we explore this possibility, we confront the potential of dark energy as not only a force shaping our universe, but also a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, that the universe goes through cosmic cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event, but rather part of a cosmic rhythm where universes expand, collapse, and then re-expand in a new cycle. This theory implies that our universe could have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, but rather an endless sequence of universes emerging, evolving, and renewing themselves again and again. Cyclic cosmology raises profound questions about time, as it suggests that time itself might be circular rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give rise to our current universe. For scientists, this theory offers an elegant solution to the question of an ultimate beginning by suggesting that there isn't one. Instead, the universe has always existed in some form, transcending our concepts of time and existence. Primordial gravitational waves are another fascinating concept that could hold clues to what happened before the Big Bang. Primordial gravitational waves are ripples in the fabric of space-time, believed to have been generated during the earliest moments of the universe. If these waves exist, they could carry information about events predating the Big Bang, such as cosmic inflation. Detecting these ancient gravitational waves would be like hearing faint echoes from an era before our current universe emerged. They could provide a direct glimpse into the processes and conditions that set the stage for the Big Bang itself. One of the leading efforts to find these primordial gravitational waves involves studying the cosmic microwave background, CMB, radiation, the afterglow of the Big Bang. This faint radiation fills the universe and contains subtle patterns that might have been imprinted by gravitational waves. Advanced telescopes and detectors, like those used in projects such as BICEP and the European Space Agency's Planck satellite, are scanning the CMB for evidence of these primordial waves. If they're found, they could offer direct evidence of inflation and, by extension, give insights into the nature of the pre-Big Bang universe. Some scientists also suggest that these gravitational waves could reveal details about the structure of space-time itself. For example, if space-time had some form of structure or grain at the quantum level, these primordial waves might carry signatures of that structure. This could potentially provide clues to a quantum gravity theory, which aims to unite the laws of quantum mechanics with those of general relativity. In other words, the study of gravitational waves might not only answer questions about what existed before the Big Bang, but also bridge the gap between the largest and smallest scales of our universe. Furthermore, concepts from quantum mechanics, such as quantum fluctuations, play a central role in our understanding of the early universe. According to quantum theory, even empty space is never truly empty. It's filled with fluctuations that can momentarily create and annihilate particle pairs. During the period of inflation, these fluctuations could have been stretched to cosmic scales, seeding the formation of galaxies and other large structures we see today. If these fluctuations existed before the Big Bang, they might have created conditions that allowed our universe to form. This leads to another intriguing concept, the idea of a quantum landscape. Some physicists believe that before the Big Bang, the universe existed as a quantum field with different possible configurations. In this view, our universe is just one configuration among many in this quantum landscape, with each configuration potentially giving rise to a different universe. This idea, sometimes called the many worlds hypothesis, suggests that the Big Bang was not a unique event, but one of many quantum bursts that could continuously occur in this landscape. Other theories propose a more radical idea, that our universe is a hologram, meaning that what we perceive as a three-dimensional reality might actually be encoded on a two-dimensional surface. This concept, known as the holographic principle, suggests that everything in our universe, including space and time, is a projection,